This video is to show an example of how to work with sine and cosine of an angle where you're given not the measurement of the angle, but just the coordinates of a point on a circle without radius 1. This is clearly a circle bigger than radius 1, in fact bigger than 14, because here's negative 14, so maybe it's 15 radius, I don't know yet. But that angle theta had a terminal side landing on some circle with coordinates at that point negative 14, negative 8. So I'm going to figure out what cosine of that angle is and also what sine of that angle is. And what we saw in the last video is that our cosine theta is negative 14, and our sine theta is negative 8. There we go. So this is a bit messy. Sorry about that. So saying that a different way, cosine theta is the x-coordinate over the radius, and sine theta is the y-coordinate over the radius. So really all we need to figure out is the radius, and we have cosine and sine of that angle without even knowing what the angle is, just starting with these coordinates. So let's figure out, well, what the heck is the radius? And the way we're going to do this is we're going to make the reference triangle by dropping down that perpendicular to the x-axis, and really just pay attention to the lengths of the sides of that triangle. So I'm going to write it here, but then write it again next door on the next page. So here's this unknown radius. I'm going to look at the length of this, and because the coordinate is negative 14, that side length is going to be 14. And because the coordinates here are negative 8, that side length is going to be 8. And so I'm going to draw that 8, 14 leg right triangle over here. I'm not necessarily drawing it perfectly to scale. Again, I don't know even what the reference angle is. I don't know even if I went a couple of turns around the circle backwards. Who knows how I got to this terminal side, but it created this reference right triangle, and that's what I'm going to focus on, and that's all I need to focus on. So I go, okay, so 8 squared plus 14 squared is r squared. 8 squared I already know, that's 64. 14 squared looks like, let's see, 14 times 14, 16, 4, 5, 14, looks like 196. At some point, if I did enough of this, I'd probably memorize that. I've got 13 squared. I know it's 169 just because I've done enough of them. So, anyway, 196. Well, 196. And I'm going to maybe need some help in just a minute with my calculator. Depends on what we come up with here. But let's see, 10, 16, 260. Yeah, let's see if we can work with r squared equals 260. So r is the square root of 260. So now let me look at that. I want to simplify that radical. Oops. Where did I get 264 from? 260. So I know 2 goes into 260. Let me see if 4 goes into 260, because I'd like to take out any perfect squares that I can from this number. So let's see, 4 would go into 24 6 times, leaving 2. Yeah, 4 times 65. So it looks like this is the square root of 4 times the square root of 65, or 2 root 65 for my radius. Root 65. And so, for example, cosine theta is negative 14 over 2 root 65, and sine theta is negative 8 over 2 root 65. Let's simplify one of these, and I typically like sine better. I don't know why. Maybe, yeah, no reason. I just know it better for whatever reason. So I'm gonna go ahead and look at that negative 8 over 2 root 65 and simplify that a bit. Negative 8 over 2 root 65. All I'm going to do is divide out that 2, schwack. So now I've got negative 4 over plain old root 65, and now I'm going to rationalize. I'm going to multiply top and bottom by the square root of 65, and it looks crazy hard. What the heck, square root of 65? But how hard is this really? Once you're used to the square root of a number times itself is that number. And so now the only thing I'm worried about is, did I get all the perfect squares out of 65? Yeah, I think so. I know 5 goes into 65, but what else really? Yeah, 5 times 13. So no other perfect squares inside 65. And I know that 4 and 65 don't have a common factor. So there is a nice simplified version of sine of this unknown angle. That all we did was we started with some coordinates of a point.